Cosmic Sprinkles. Introducing dwarf galaxies. Our universe is a vast and mysterious place. It's filled with billions of galaxies, each containing billions of stars. While we often focus on the grandeur of massive spiral galaxies, like our own Milky Way, the universe also harbors a plethora of smaller, fainter galaxies known as dwarf galaxies. Dwarf galaxies are like the little siblings of the galactic family. They are much smaller and less massive than their larger counterparts. Think of them as the cosmic equivalent of fireflies, scattered throughout the universe, twinkling with their own unique light. These galactic dwarfs may be small, but they hold valuable clues about the formation and evolution of galaxies as a whole. By studying these miniature galaxies, astronomers can gain insights into the processes that govern the birth, life, and death of all galaxies. Galactic Laboratories. Why dwarf galaxies matter. Dwarf galaxies are cosmic laboratories. They offer a unique window into the early universe. Because dwarf galaxies are smaller and less complex than larger galaxies, they provide a simpler environment in which to study the fundamental processes of star formation and galaxy evolution. One of the key reasons why dwarf galaxies are so valuable to astronomers is their high sensitivity to their surroundings. Unlike massive galaxies, which are relatively resistant to external influences, dwarf galaxies can be easily affected by the gravitational pull of their neighbors or the energy released from nearby supernova explosions. By observing how dwarf galaxies respond to these external forces, astronomers can learn more about the interplay between galaxies and their environments. This information is crucial for understanding how galaxies grow and evolve over cosmic time. Small but mighty. Characteristics of dwarf galaxies. Dwarf galaxies, as their name suggests, are small. They typically contain far fewer stars than their larger counterparts, ranging from a few 100,000 to a few billion stars. In contrast, the Milky Way is estimated to contain hundreds of billions of stars. Despite their diminutive size, dwarf galaxies can be surprisingly diverse in their properties. Some dwarf galaxies are actively forming stars, while others are relatively quiescent. One of the most intriguing aspects of dwarf galaxies is their high dark matter content. Dark matter is a mysterious substance that does not interact with light, making it invisible to telescopes. However, its gravitational influence can be detected in the rotation of galaxies and the movement of galaxy clusters. A galaxy of shapes and sizes. The diversity of dwarf galaxies. Dwarf galaxies come in a variety of shapes and sizes, each with its own unique characteristics. Some of the most common types of dwarf galaxies include dwarf elliptical galaxies, dwarf irregular galaxies, and dwarf spheroidal galaxies. Dwarf elliptical galaxies, as their name implies, have a smooth elliptical shape and are generally lacking in gas and dust. These galaxies are thought to be ancient relics of the early universe, having formed most of their stars billions of years ago. Dwarf irregular galaxies, on the other hand, are characterized by their irregular, often chaotic appearance. These galaxies are typically rich in gas and dust and are actively forming new stars. Dwarf spheroidal galaxies are similar in appearance to dwarf elliptical galaxies, but are even fainter and more diffuse. They are thought to be some of the oldest and most dark matter-dominated galaxies in the universe. Section 5. Stellar Nurseries, Star Formation in Dwarf Galaxies. Dwarf galaxies may be small, but they can be surprisingly prolific star-forming engines. In fact, some dwarf galaxies have star formation rates that are much higher than those of larger galaxies. This enhanced star formation is thought to be due in part to the lower metallicity of dwarf galaxies. Metallicity refers to the abundance of elements heavier than hydrogen and helium in a star or galaxy. Stars in dwarf galaxies are typically born with a lower metallicity than stars in larger galaxies. This is because dwarf galaxies have less gravity to hold on to their interstellar gas, which is enriched with metals as stars evolve and die. The lower metallicity of dwarf galaxies has a significant impact on star formation. Metals are more efficient at cooling and collapsing gas clouds, which are the raw materials for star formation. As a result, gas clouds in dwarf galaxies can cool and collapse more easily, leading to higher rates of star formation. Section 6. Building blocks of the universe. The role of dwarf galaxies in galaxy evolution. Dwarf galaxies are not only interesting in their own right, but they also play a crucial role in the formation and evolution of larger galaxies. According to current cosmological models, galaxies like our own Milky Way were not born fully formed. Instead, they are thought to have assembled over billions of years through the mergers of smaller galaxies, many of which were likely dwarf galaxies. These mergers can have a profound impact on the structure and evolution of the larger galaxy. For example, the infall of a gas-rich dwarf galaxy can trigger a burst of star formation in the larger galaxy, while the merger of a dwarf galaxy with a massive black hole at its center can fuel the growth of the black hole and create an active galactic nucleus. By studying the properties of dwarf galaxies and their interactions with larger galaxies, astronomers can gain a better understanding of how galaxies like our own came to be. Section 7. Meet the dwarfs. Examples of dwarf galaxies. The universe is teeming with dwarf galaxies, each with its own unique story to tell. Here are a few notable examples of these fascinating objects. The Large and Small Magellanic Clouds. These two dwarf irregular galaxies are the most famous examples of dwarf galaxies and are visible to the naked eye from the southern hemisphere. They are both actively forming stars and are engaged in a complex gravitational dance with the Milky Way, M32 and NGC 205. These two dwarf elliptical galaxies are satellites of the Andromeda Galaxy, the nearest major spiral galaxy to our own. They are both much fainter than the Andromeda Galaxy, but are still visible through small telescopes. Segway 1. This ultra-faint dwarf galaxy is one of the most dark matter-dominated galaxies known. It is located in the constellation Leo and is so faint that it was only discovered in 2006. These are just a few examples of the many fascinating dwarf galaxies that populate our universe. Each of these galaxies provides a unique window into the workings of the cosmos and helps us to piece together the story of how galaxies form and evolve. Section 8. The little galaxies that could recap and importance. Dwarf galaxies may be small, but they are mighty. These cosmic underdogs hold crucial clues to understanding the universe's grandest mysteries. Their diverse shapes, sizes, and star-forming properties offer a glimpse into the complex processes that govern galaxy evolution. From their role as building blocks of larger galaxies to their status as cosmic laboratories for studying dark matter and star formation, dwarf galaxies are essential to our understanding of the cosmos. Their small size belies their significance in the grand scheme of the universe. As we continue to explore the universe with ever more powerful telescopes, we can expect to discover even more fascinating dwarf galaxies, each with its own story to tell. These discoveries will undoubtedly deepen our understanding of the universe we live in. Section 9. Keep exploring. The future of dwarf galaxy research. The study of dwarf galaxies is a vibrant and rapidly evolving field. New discoveries are being made all the time, and our understanding of these fascinating objects is constantly improving. As we look to the future, there are many exciting avenues of research that promise to further illuminate the mysteries of dwarf galaxies. One area of active research is the search for even fainter and more distant dwarf galaxies. These ultra-faint dwarf galaxies, are thought to be relics of the very early universe and could hold crucial clues about the conditions that prevailed in the aftermath of the Big Bang. Another promising area of research is the study of the interplay between dwarf galaxies and their environments. By observing how dwarf galaxies interact with the gas and stars around them, astronomers can learn more about the processes that drive galaxy evolution. Finally, the development of new and more powerful telescopes will undoubtedly lead to revolutionary discoveries in the field of dwarf galaxy research. These telescopes will allow astronomers to study dwarf galaxies in unprecedented detail, revealing their secrets and shedding light on the fundamental workings of the universe.